This third film on industrial communication will cover industrial Ethernets. And we will compare it to traditional Ethernet and advantages and disadvantages compared to the serial communication protocols. And then some basic cables and connectors. The advantages: bitrate, up to 1 gigabit per second and even 10 gigabit per second, but I haven't seen that for industrial applications. And it's much faster than most serial protocols, the, let's say, older protocols. It has a generally good overall performance. It has 90 meters segment length, so it can communicate for 90 meters without repeaters. You have standard products, the mass-produced products that you will find everywhere: routers, switches, gateways, cables. Unlimited number of nodes, nearly 4.3 billion, and who has 4.3 billion sensors in a network. Host to host, not master slave, so each and every device in such a network has the same priority. TCP is not real time, so it's not a real time system. There is a parallel protocol called UDP, which can be used instead of TCP, which is a bit better, but still it's not full real time, which means that it's not absolutely predictable how long time it takes for a data packet to go from the sender to the receiver and the acknowledgement to come back to the sender again. It's more complex. Well, in most cases that doesn't matter to us as an end user. And then you have large data packets. If you see here, the fast Ethernet packet has about 80 bytes of data at the minimum. And that is with the sender's address, the receiver's address, the packet size, the length of the packet, and all sorts of data associated with each and every packet. While in industrial applications, you actually usually have a bit or two to send, maybe just one bit. So, for example, set the switch or set the valve to off, open, close. So that's only one bit, and you get 80 bytes of additional data. So the amount of more or less pointless traffic is enormous in such a network. The cables are generally more robust, but you can use traditional Ethernet cables, but generally they are more robust, which means that they can handle temperature, light, solvents, moisture, mechanical stress and vibration better than traditional cables, but they are also stiffer and more difficult to handle. Copper and fiber is used. Connectors. You can use some networks use the older RS-232 connector, but with an Ethernet setup. It's not very common. You have something called the M12 connector, which is quite common, and also the RJ45 plug, which is the same as in the office network, but then often with some kind of screen and lock system to make a better and more rigid connection. Access method. When a device wants to connect to the network, you have something called a probabilistic and something called a deterministic. Let's do deterministic first. The packets on the network will never be sent unless they have been given permission to do so. So, for example, in an earlier film we talked about the master-slave protocol, and that is when one master is the only one in the network that can initiate communication, and the reply comes from one of the slaves. Or client server, if you like. So that is deterministic. The network communication will never occur unless it's been initiated by the master in such a network. While in a stochastic network or probabilistic, it works on the principle that it will probably work. So a packet is dumped onto the network, Maybe the network is already busy. Well, then you get something called a packet collision, where two packets meet in the cable, and the packets, both packets actually will be lost. The data will become corrupt. Okay, it's worth the risk, because the only thing, the best thing to do is to resend the packet once it's discovered that it never reached its destination. So for internet purposes, this is perfect. We don't have to want to wait for permission to send data onto the network, but send it once we have data available. Then, okay, there is a risk of losing packets, but we can simply resend them. In an industrial setup, this is not ideal, because it cannot guarantee delivery time, so it's not real time. A closer look at the Ethernet packet, you see what that it has all kind of additional information to it, and simply here is a small slot here that covers the data. This is the actual data that you want to send from the sender to the receiver. All the extra information here are, for example, source and destination address, and some options that comes with it, and so on. The data here, the size of the data block may grow. So if you have much data to send, it can cover more data here. But still, the minimum amount, if you only want to send 1 bit, you also have to send all this extra information here. So therefore, the amount of data sent is very, very, very much. So the effective bandwidth is less than 5%. So from site to site in an industrial application.